we're going to talk about parabolas, but more specifically, they're called quadratics. Quadratics, parabolas. Okay, parabolas are technically the graph. Parabolas are the graph, and quadratics are any x squared equation. Okay, any x squared. So I want everybody to watch. We're going to do the parent function. We're going to do a t-table in our brain because we're smart. So you see where my pin is? It's right at 0, isn't it? What's 0 squared?
0.
So there's a point called 0, 0, right? If I shift over 1, 1 squared is?
1.
So I have a point at 1, 1. If I move over 2, 2 squared is?
4.
So I go up 1, 2, 3, 4. See how easy this is? If I go over 3, what's 3 squared?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Now parabolas are symmetrical. Here's why they're symmetrical. Negative 1 squared is positive 1, right? Go over to negative 2. Negative 2 squared is positive 4. 1, 2, 3, 4. Okay? Negative 3 squared is a positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my parabola is not a V. It curves. It curves. It looks like this. Okay? Now, some key features, all right? This bottom point is called the vertex. This bottom point is called the vertex. Okay, this bottom point is called the vertex. It is at the coordinate 0, 0 in this parabola, okay? It's symmetrical, which means it can be folded onto itself. So it has a line of symmetry. The line of symmetry just goes straight down the middle. The line of symmetry always goes to the vertex. Always goes to the vertex, okay? That's my line of symmetry. Line of symmetry, okay? It has an equation. It's an x equal equation. In this case, it's just x equals 0 because it goes through 0, okay? So, it has a vertex. That's the very bottom point. That's at the coordinate 0, 0. It has a line of symmetry. It goes right down the middle of it because it is symmetrical. And in this case, it's an x equal 0. It's always an x equal equation because it goes vertically, okay? Now, what we want to do in example 2 is we want to move it, okay? We're going to take our parent function and we're going to translate it, or we're going to move it, okay? Listen. Whatever's on the inside, listen. Whatever's on the inside, we're going to do the opposite. And we've talked about this before, but we're going to talk about it again, okay? If it's on the inside, we go to the opposite. The reason why is because the value of 4 will zero it out. The value of 4 would zero it out. That's why it's the opposite. So our vertex of this one is at positive 4, 1. It's the opposite of the inside number. It's the opposite of the inside number, okay? Always. Because the value of 4 zeroes it out, okay? So when I can go to my vertex at 4, 1, 1, 2, 3, 4, 1, and put my vertex down. So what I want to do is translate this parabola onto this graph. So I'm going to do my same t-table. I'm going to go 1, 1, 2, 4, 3, 9, right? Negative 1, 1, negative 2, 4, negative 3, 9. I'm going to put my parabola right there. So from my vertex, I go 1, 1. Why do I go 1, 1? Because 1 squared is 1. From my vertex, I go over 1, 2, and 2 squared is 4. 1, 2, 3, 4. If I go over 3, I'm at 9. It's kind of off my paper, but I'll do it anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe up here. Okay, I need a little bit bigger graph if it works. Okay, now, they're symmetrical, right? Because I know if I go back 1, 1 squared is still 1. From my vertex, if I go over 1, 2, 2 squared is 4. 1, 2, 3, 4. If I go back from my vertex, 1, 2, 3, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, because 3 squared is 9, okay? So, I found my vertex from the opposite of this number and that number. That's my vertex. It's called vertex form. And then I just did my parabola. 1, 1, 2, 4, 3, 9, because 1 squared, 2 squared, 3 squared. And I just draw it in carefully, okay? There it is. All right. It has a line of symmetry. Draw that in. The line of symmetry is just a dashed line. And the line of symmetry is x equals 4. it's always going to be the x value of your vertex because it's got to go through your vertex. Has to go. Has to go through your vertex because that's right at the bottom, cuts it right in the middle, right? Okay, now how am I doing so far? You guys can do this. You can. Now, example 3. What's the difference? What's the difference? Yeah. There's a 2. So this one's just going to be twice as tall. Twice as tall because of the 2 in front. So instead of going 1, 1, 2, 4, I'm going to go to 1. But instead of going up to 1, I'll go up to 2, right? So going up 4, I'll go up 8, right? Instead of going up 9, I'll go up 16. Twice as tall, right? So first of all, the vertex. Where's the vertex? -3, -5. Opposite. Nice job, Jackson. It's got to be the opposite of the inside value because -3 would zero it out, right? It's got to be the opposite inside. Yes, Josie.
If there's like not a -5, then would it just be 0?
Yes. Yes. Very good. So, -3, 1, 2, 3, 1, 2, 3, 4, 5. Okay, there's my vertex, right? Now I need to make it twice as tall. So from my vertex, and I'm going to do it in pencil first. 1, 1, don't write this down. 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't write this down. Let me get it down because I want you to see how we go twice as tall, okay? All right. I've got mine in pencil. So if I go over 1, I go up 1, but I want to go twice as tall. So going up 1, I'm going to go up 2. So instead of going up 1, I went up 2. 2, instead of going up 4, I'm going to go up twice as tall. 8, 4, 5, 6, 7, 8. Okay. And then instead of going up 9, I got to go up 18, but that's off my paper, right? That's way up there. So I'm not even going to graph. It's too high. So let me erase these because you're right, Jackson. I don't really want these, do I? I don't want these at all. I want the ones that are twice as tall, right? Twice as tall. Same thing on the other side. Up 1, but I don't want to go up 1. I want to go twice as high. So go to 2. Over 2, up 1, 2, 3, 4. But let's go up twice as tall, which is up to 8. 4, 5, 6, 7, 8. And then this is up 9, but twice as high would be 18, but it's going to be off my page. So I'm just going to erase the rest of these. Erase, erase, erase. Right, so it doesn't look much different, but it looks skinnier. But skinnier in this case, it means taller. There you go. Example 4. I see a couple of things going on. Josie, you just mentioned the other. So the vertex. Josie, what's the vertex at?
For this one?
For this one.
3 and 0.
3, 0. Because there's no number here, right? There's no number, so how about a plus 0? Does that make sense? Okay. How's Alyssa doing? Alyssa, how you doing? Good? I know, it was early this morning for all of us. So let's go 2, 3, 0. That's right there. Well, what do you think these features mean? I got a 1/2.
This is going to be negative, so let's make it
Upside down,
of what it should be.
half as tall. Upside down because of the negative, so it's going to be upside down. Or if we want to get mathematical, we say it's a reflection over the x-axis. It's going to be reflect over the x-axis. Or upside down is easier, okay? And it's going to be half as tall. So 1, 1 is really going to be 1 down 1/2. 2, 4 is really going to be 2 but down 2 because half is tall, right? 3 down 9, I'm going to go down 4.5 because it's going to be half as tall. So instead of going over 1 down 1, I'm going to go over 1 down 1/2. Go over 1 down 1/2. 1, 2. If I'd go 2 squared is 4, but I'm not going to go 1, 2, 3, 4. I'm going half of that. So I go 1, 2. Go 1, 2, 3. 3 squared is 9, so I'm not going to go 1, 2, 3. I'm not going to go down 9. I'll go half at 9, which is 4.5. 1, 2, 3, 4.5. And of course, it's symmetrical, isn't it? So I do know I'll have another point right there at 1/2. Another point there at down 2. Another point right there, okay? Not bad. They all have the same shape. They're all parabolas, okay? Thumbs up. Okay, turn the page. Ready, Anna? You got it? Okay? Example 2. If a parabola is stretched vertically, that means it's going to be taller by a factor of 3, then translated to the left 4 and down 2, okay? So let me just make a little sketch of this. Let's see. We're going to have it left 4, 1, 2, 3, 4, and down 1, 2, it's right here. And it's going to be stretched, so it's going to be tall, okay? It's going to kind of look like that. Not a very good drawing, but it's kind of look like that. Can we come up with that equation? Well, I'm going to start here. I'm going to start right there. Oh, you can't see that. I'm going to start right there. Y equals parentheses x something parentheses squared. Has to be squared. Has to have the square because we know it's a parabola. Has to have a square there because parabolas have squares. Okay, there's squared graphs. Now, if it's back 3, we do the opposite, don't we? So I need a plus 3. You guys agree with that? I need a plus 3 here. And then I'm down 2, so I go minus 2 for the equation, right? And then what goes right here? What goes right here? So it's 3, isn't it? Right? It's stretched by 3, so a 3 goes there.
It needs to be a positive 4 in the parentheses.
Oh, thanks, Jackson. I don't know why I made that mistake. I'm with you guys. I had to get up an hour early this morning, huh? I know. How about 6? What about an equation for 6? What's one thing you see on 6? Y equals what? What's one thing you see on 6? Yeah, negative. Negative's totally right. In fact, it is negative 1, but we can show why it's negative 1. You're totally right, Gage. Okay, where's the vertex? My vertex is at 3, 1, isn't it? I agree with the negative 1. So what goes inside of here?
X minus 3.
X minus 3 squared, right? It's got to be squared because it's parabola. And then what? Nice. That's exactly right. And can I test the 1? I want to test the 1 because maybe it's 1/2. Maybe it's 1/3. But I'm going to test it. Watch this, Gage. 1, 1. Haha, 2, 4. Like that. 3, 9, which means it's got to be the regular parabola, doesn't it? And I do the same thing. 1, 1. 2, 4. 3, 9 is perfect. It's got to be 1. You agree? Because it's a parabola with its normal scale, okay? All right. Now, do the homework. We got lots of time. Before you start goofing off, getting out your phones, get it done, all right? Questions? Okay, again, this is just Algebra 1 stuff. We've done